Welcome to Meteorology Matters. Ever wonder about the history of hurricanes in the Caribbean? I mean, way back, even further than our records go.
Yeah, that's a great question because the Caribbean is, it's been a hotbed of hurricane activity for as long as we've been keeping track, really.
Exactly. But today we're going to dive into some really cool research that takes us back thousands of years.
Thousands, yeah, way back 5,700 years to be exact.
Wow, that's before the pyramids. So how is that even possible? I mean, our weather records only go back a couple of centuries at
Well,
most, right?
right, like our good instrumental data only goes back about 73 years, and historical accounts maybe like 173 years.
So how do we jump from that to 5,700 years? What's the secret?
The secret's actually hidden in plain sight. It's the Great Blue Hole.
The Great Blue Hole. You mean that incredible natural wonder off the coast of Belize? The one that Jacques Cousteau made famous?
The one and only. It turns out it's not just a stunning diving spot, it's also a time capsule for hurricane history.
So we're talking like a giant sediment core.
Exactly. A 30-meter-long core that gives us a year-by-year record of storm activity.
Wow. So each layer of that sediment is like a page from a hurricane diary. That's way beyond anything we had before. You mentioned 2,000 years was the furthest back scientists had looked.
Right. Even the best studies before this one only got us back about 2,000 years. So this new data more than doubles our understanding.
Incredible. But before we go any further, can we back up a sec? I'm still wrapping my head around this. How exactly does a sinkhole record hurricanes?
Oh, sure. So the Great Blue Hole sits on Lighthouse Reef,
Right.
right? And because of its location and the way sediment settles in it, it's super sensitive to any tropical cyclone that passes by.
Okay, so when a hurricane hits,
Exactly. When a hurricane hits, it stirs up all this sediment and debris from the reef and the coastline. All that heavier stuff gets washed into the blue hole, which is relatively calm, and it settles down in layers.
so each hurricane leaves its own unique fingerprint in the sediment.
Exactly. And those fingerprints, they add up over time, creating this incredible record.
Okay, so now we have this 5,700-year record. What is it actually telling us? What's the big picture when it comes to Caribbean hurricanes over that time span?
Well, the main takeaway is that there's been a clear trend of increasing storminess in the southwestern Caribbean over those millennia.
So basically more hurricanes over time?
Yeah, like a slow but steady increase in the number of hurricanes over thousands of years.
Wow. But what's causing that? I mean, that's a seriously long-term trend. Is it just random chance?
That's where it gets really interesting. The researchers link this increase to changes in Earth's orbit.
Wait, hold on. You're saying the way our planet moves around the sun affects hurricane activity in the Caribbean?
Absolutely. It's about the Intertropical Convergence Zone, or ITCZ for short. It's this belt of clouds and rain near the equator. You see, over thousands of years, subtle shifts in Earth's toot and wobble, we call those obliquity and precession, affect how much solar radiation different parts of the tropics get. That, in turn, influences where the ITCZ sits. It's like this really slow but powerful steering wheel for global weather.
Okay, so if this ITCZ moves, what happens to hurricanes?
Well, the main breeding ground for Atlantic hurricanes is closely tied to the northern edge of the ITCZ.
Ah, so as the ITCZ shifted south over time.
Bingo. That prime hurricane-forming zone also shifted south. And that means more storms were likely to end up in the southwestern Caribbean.
That's amazing. So it's like this cosmic dance between Earth's orbit and hurricane pathways playing out over millennia. You mentioned that records from Puerto Rico show a similar trend to Belize, so this is happening over a large area. But you also said that this increase in storminess isn't uniform across the entire Atlantic. What's up with that?
It's super important to remember that. While Belize and Puerto Rico, being at similar latitudes, show this clear upward trend in hurricanes, places further north, like Florida and the Bahamas, tell a different story.
How so?
Well, over the same 5,700 years, their records either show more stable hurricane activity or even a slight decrease.
So the Caribbean is getting hit more, but other places maybe not so much. That suggests that something more complex is going on than just a general warming of the Atlantic Ocean, right?
You got it. It's not just the overall Atlantic sea surface temperature that matters. It's also these large-scale atmospheric patterns driven by things like the ITCZ that really influence where hurricanes form and where they go.
That's a great point. So we've been talking about these really long-term trends spanning thousands of years. But what about shorter-term fluctuations, like those happening over decades or centuries? Did the researchers find anything interesting there?
Oh, absolutely. On top of that long-term increase, there are these shorter-term swings in hurricane activity, and they seem to line up with known climate periods during the Holocene Epoch, which is roughly the last 11,700 years.
So basically, it's not just those massive orbital shifts that matter. Other climate factors can also make a difference in how many hurricanes we see over shorter periods.
Yeah, exactly. Things like variations in how much solar energy is hitting Earth, which affects sea surface temperatures, and different modes of climate variability all likely play a role in these shorter-term changes in storminess.
Can you give an example of how these shorter-term climate factors have affected Caribbean hurricanes in the past?
Sure, let's look at the last 1,200 years. The Great Blue Hole record matches up really well with the overall hurricane activity across the whole Atlantic basin, as well as a regional record from the Yucatan Peninsula. For example, during the medieval warm period, a time when global temperatures were generally warmer, both the Great Blue Hole and the wider Atlantic saw more hurricanes. But then during the Little Ice Age, which was a cooler period, hurricane activity in both the southwestern Caribbean and the entire Atlantic tended to drop.
Fascinating. So it seems like factors like solar activity and these large-scale climate oscillations have a real impact on how many hurricanes form, not just over thousands of years, but also over shorter time frames. Yeah. So all this talk about past hurricanes is really interesting, but what does it tell us about the future? Especially with all the concerns about climate change. I mean, is the Caribbean in for even more hurricanes as the planet keeps warming?
That's the million-dollar question, and the researchers did tackle that. They looked at the recent high levels of hurricane activity in the southwestern Caribbean and made a projection for the 21st century.
And what did they find?
Well, their projection suggests that we might see a huge increase in hurricanes, maybe even an unprecedented increase.
Unprecedented. That sounds pretty serious. What's driving that projection?
The main factor is what we've all been talking about, global warming. As temperatures climb, the sea surface temperatures in the main hurricane development region are getting exceptionally warm. And as we know, warm water is like rocket fuel for hurricanes.
So warmer oceans, more hurricanes. Makes sense. Anything else feeding into this projection?
Yeah, the National Oceanic Atmosphere Administration, NOAA, predicts that tropical Atlantic sea surface temperatures will keep rising over the next few decades. Plus, they're expecting more frequent La Niña events, and historically, those tend to boost hurricane activity in the Atlantic.
So it sounds like a perfect storm, so to speak, of factors that could lead to a lot more hurricanes.
It does seem that way. Their worst-case scenario estimates something like 45 hurricane strikes in the southwestern Caribbean between 2000 and 2100.
45. Wow, that's a lot. And how does that compare to the natural variations we've seen in the past?
It's much higher than anything we've seen in the Holocene, even during those periods of increased activity we talked about earlier.
That's sobering. But I'm curious, did the researchers explore any other possible scenarios, maybe ones that aren't quite as dire?
They did. One alternative scenario involves a more dramatic warming in the northern Atlantic compared to the tropics. This could shift hurricane tracks and those zones where hurricanes reach their peak intensity further north.
So basically, hurricanes might bypass the Caribbean and head north instead.
It's possible. In that case, the southwestern Caribbean might actually see a decrease in hurricanes. However, that would likely mean more hurricanes, maybe even stronger ones, hitting the northern Atlantic, so it's a trade-off.
Right, so no matter what, it seems like we're in for some significant changes. You know, this whole discussion has really highlighted just how valuable this Great Blue Hole record is. Yeah. But I'm curious, how did the scientists actually get all this information about ancient hurricanes from that sediment core? What were the key techniques they used?
It's a really impressive process involving what's called a multi-proxy approach. The first step was looking for visually distinct event layers in the core.
You mean layers that look different from the normal sediment?
Exactly. These layers often have a different color, and they lack that fine annual layering, the lamination, that you see in sediment deposited under calm conditions. So these visually different layers are like the first clue.
Got it. So what other evidence did they look for to confirm that these layers really were from hurricanes?
Well, next they did a careful analysis of the sediment's texture, looking at grain size. Hurricane layers typically have coarser stuff like sand and gravel, often even bits of shell and coral that were ripped up by the storm surge.
Right, so those heavier materials would get carried into the blue hole by the storm waves? Did they measure anything specific about the grain size?
Yeah, they measured the average grain size and the percentage of this coarser material in each layer. These different proxies, the visual appearance, the grain size, each tell part of the story. And by putting them together, they get a much clearer picture than they would from just one.
That makes sense. It's like having multiple witnesses to confirm the same event. Was there any chemical analysis involved as well?
Oh, yeah. They looked at the ratio of strontium to calcium in the sediment. Higher ratios of strontium usually mean more reef material was washed into the blue hole during storms. Reefs tend to be richer in strontium, so that's another sign of a hurricane.
And do they use any other techniques?
They also used gray-scale analysis. Basically, they took X-ray images of the core, and variations in the shades of gray reflect changes in the sediment's density. Storm layers often have a unique density signature compared to the surrounding sediment.
Wow, so they really threw the whole scientific toolbox at this, huh? So they have these visual clues, grain-size data, chemical analysis, even density measurements, all pointing to past hurricanes.
Exactly. It's a very thorough approach.
Makes sense. But how do we know this record actually goes back 5,700 years with that impressive annual resolution you mentioned? How did they figure out the timeline for all these hurricane layers?
Well, for the annual resolution, they mainly relied on counting varves, those annual sediment layers I mentioned. But to be extra sure, they also used radiocarbon dating at different depths throughout the core.
So carbon dating to double-check the age of the sediment. That's pretty standard, but were there any other methods they used for confirming the timeline?
Yeah, they used a few other clever tricks. For example, they looked for pollen from plants linked to human agriculture. Those show up at known historical periods and can be used as timestamps. They even found ash from the 1982 eruption of El Chichon volcano. It acts like a time marker, helping confirm the accuracy of their timeline. By combining all these different dating techniques, they could be confident in the age and that yearly detail of this amazing record.
It's like a historical jigsaw puzzle, and they found all the pieces. But one last question. How do we know for sure that these layers really represent hurricanes and not just some other random disturbances in the ocean? I mean, could it have been something else that stirred up the sediment?
That's a great question. To check the reliability of their findings, they compared the top part of the core, the most recent sediment, with actual hurricane records from 1950 to 2022. And guess what? There was a really strong match, with something like 84% of the storms that passed near the blue hole being recorded in the sediment.
84%. That's pretty convincing. So it's safe to say that most of those layers throughout the core are accurate records of past hurricanes.
Yeah, it gives them a lot of confidence in their data. They even found that hurricanes approaching from the south were more likely to be recorded than those from the north, likely because of the shape and position of the blue hole. There were a couple of layers that didn't perfectly align with known hurricanes, and they think those might be from other events like intense winter storms or even distant earthquakes, but the vast majority line up really well with the historical hurricane record.
That's some amazing detective work. So as we wrap up, what are the big takeaways from this 5,700-year hurricane record? What can our listeners learn from this peek into the deep past?
I think the biggest lesson is that hurricane activity in the Caribbean is influenced by so many factors, from these slow, grand shifts in Earth's orbit to shorter-term climate cycles and even human-caused climate change.
It really shows how interconnected everything is, right? From the movement of our planet to the intensity of storms and even the future risks for people living in hurricane-prone areas.
Exactly. And it's a reminder that understanding the past can help us better prepare for the future.
Absolutely. The fact that a sinkhole can hold such a detailed and long-lasting record of these powerful events is just mind-blowing. If you found this exploration of past hurricanes intriguing, be sure to follow meteorologist Rob Jones on Instagram, meteorologist, on TikTok, TV meteorologist, and on YouTube, follow Rob Jones Hurricane, where you can also find the Meteorology Matters podcast playlist. There's always more to learn about the forces that shape our weather. Until next time, keep exploring the world around you.